Hello, in this video I'm going to go over how to create sound and music on the MegaDrive. So first off, I will go over some details on what hardware we've got to work with here, and then I'll show you a demonstration program with a SoundManager in there which you can use, and I'll first show you how to use it and then go over how we can add new VGM files and wave files for sampled sound effects. So first off, we'll quickly go over the hardware here. So the MegaDrive's got a Z80 inside of it to make it backwards compatible with the master system, but it also acts as the sound controller. So we've got the PSG chip inside, which has 3 tone channels and 1 white noise channel, and we also have an FM chip, the Yamaha YM2616, which has 6 stereo sound channels which can play 8-bit sound samples. It has 8 kilobytes of dedicated sound RAM to work with, the Z80, and it runs at 4 megahertz. So I'll quickly go over some PSG stuff, as I won't be diving into all of the technical specs for the Yamaha chip. I'll purely be showing how we can use it in code, as I've no idea the exact bits and pieces that we need to do to actually code sound with it. So the PSG on the MegaDrive, one way we can access it is by sending bytes sequentially to this port here. So it turns out that the sound chip, the PSG, is actually mapped to the 68000's address bus, so you can send bytes to it directly there. I did a video on the PSG on the Master System and Game Gear, which is very similar, but the way that we access it is kind of different, because obviously the Game Gear and the Master System are running off of the Z80, so the way that you send bytes to it in sequences, but to a different port. So to use the PSG, you have to send bytes at a time in a sequence to first turn on the volume for the specific channel you intend to use, and then if you're writing to a tone channel, then you need to send 2 bytes, one after the other. The first byte would contain the channel ID and a latch bit, which would be set to 1 to indicate that it was you'd be wanting to use one of the sound channels. And if you wanted to access the noise channel, you would just send 1 byte. The bytes themselves have individual bits set in them, set up to do certain tasks, and if I scroll down here, we'll touch over them here. So the latched byte format is this here. So the first byte you would send to the PSG, you set the latched bit on the first byte to 1 to say that it's a data byte, and then this is set to 0 here. The type flag would be 0 to say that it's data, and then these D bits are part of the tone value, and then the other byte, these parts here make up the other part of the sound. So it's the tone registers are 10-bit tones, which can form a number between 0 and 1023. If you are sending data to only the noise channel, then you don't need to send the second byte, because the only range of values are between 0 and 15, using these bits being set to create the white noise sounds. So now that I've quickly gone over the PSG side of things, I'll first show you the demo running, and then we will go over the code and also how I created the music briefly. So first off, we'll open the ROM there with Blastum. So we've got a load of info here. So there's a number of different PSG tracks in here. So I'll play them first. So I included the PSG purely in case you wanted to play around with creating your own sort of chip sounds without using a tracker, which is how you would have to write music for the MegaDrive yourself if you were going to do it. You would use something like Devil Mask to create a VGM file for playing music. So I'll go over the sound effects now. So the sound effects are wave files which have been converted by the resource compiler in SGDK, which is some of the things I'll need to go over shortly. So we can create, or rather use, wave files which are converted to 8-bit by ourselves, and then the resource compiler then allows us to so every time you press up, it will play a random sound effect from the list of sound effects. And then I've included the 2 VGM tracks here. You can find a load of different VGM resources online for the MegaDrive, and then just download them to test with yourself. So any of the games that you can think of for the MegaDrive, you'll probably be able to find a ripped VGM file from that. So I will give you an example now. And then I'll start that one, and then I'll start the other one briefly. Right, now we will dive into the code, and I'll show you how we can add an additional wave file. So first off, I'll open the project in code blocks. So I'll go over the SoundManager, which is the obviously the main point of this video is to provide you with a means to play sounds yourself. So some of these are related to the PSG. All of these here are related to using the PSG. It's the same code pretty much from the my Master System videos here. So I'll quickly go over some of this here. So as I said, there's PSG has 4 channels. The first 3 are the tone channels, and then the last one is the noise channel. So I've created an array of notes here. These values map to octaves and go from, open the other part a minute. and then this here is the mapping of these words here, or unsigned shorts rather, as they're called in C. And then there's also an array here for note play delays and the pause delays after a note is played, which are these here. So you could either put this in for a delay yourself, or rather these here represent these bytes here pretty much. These are offsets into this array, and these enums here are offsets into this array here. And then the music for those songs are composed using those delay parts and also the notes. So to create your own music using the PSG, you would literally either need to be able to read sheet music, or you would need some of these references which are found online, which enable me to kind of decipher sheet music. So this one here gives me an idea of how long a note should play for. And then this image here shows me what note is to be played. So if I open this one up and if I open this sheet music up a minute quickly, this one's a relatively easy sheet here because it's just using the treble clef one here, which is kind of one-handed. So in lots of the sheet music it appears that there's like two sort of lines here, one with treble clef and another with this bottom one here, which signifies where on the keyboard the hands should be, as one is in one octave and then the other is in another octave. So the octaves are how high or low a note actually is. So using this here and these parts, I was able to deconstruct that sheet music into this array here. So the music always consists of a pause, then a rest, and then the actual note to play. So each action of playing the music needs these three parts. And then once we finish the song, just chuck in three ends there. All of these here are using this here to make composing it easier. So also because it's because of the way that all of this is handled, your songs are limited to 255 bytes as well, so that's something to be aware of. You could always change the if I come down here a minute, this, where is it? Okay, one of my other videos had a different data type for holding the sound, but that's not the case here, so there isn't really an issue with the length of sound, it would appear. Okay, so yeah, there's no sort of restriction on how long your chip tunes could be. But anyway, this is how they're sort of composed if you should want to do that. And there's also methods here for turning them on. So you can use this command here. First off, you put a channel number in between 0 and 3. Although for a tone channel you would literally just have 0, 1 or 2. The volume is between 0 and 15. The delay is how long the note will play for. And then the frequency is a number between a 0 and 1023. Or you could always use one of these values here to access this array directly. And then most of these here all handle the playing with the PSG. These commands here are specific to the FM chip. So I'll now get into how we can use these things here. So to begin with, always call the initialization function first before you use it. If I jump into the main part of the code here, there's not a lot in this. So first off, you need to call SoundInitialize function, and then make sure you have sound update just before the system do vbank process. And then to play a song, you pass what sound channel you want, the volume, and then the byte stream. So in the main header file here, these are all external arrays here to our music, which is in here. Now now we'll get into the more interesting things of playing the sound effects and VGM files. So if I open up the if I show you the project here, so this is the Code Blocks project here. Obviously if you were using a different compiler to build your MegaDrive programs, then you might have things laying around slightly differently. So when we're requiring to use assets, we have to create a res folder, and then in the res folder here, to keep it nicely separated, I create a sound effects folder and a music folder. And in your sound effects folder is your WAV files that you want to include in your project, and then the music folder are our VGM files. Now to be able to use any of these, we need to create a res folder, a res file. This is for SGDK's resource compiler program. It's just a text file really, so this is the key takeaways from this. So these top lines here, we're going to put the top ones here as XGM file types. So if you look in SGDK, they have there's a file for the resource compiler, and in that there will be a list of resource types that it can actually handle, and the format for it is the resource type first. This is the name that you will use internally in your program, and this is the local path to that asset. So if I do these windows side by side here, So if we go to the play music part a minute. As in the playing the VGM file. So SGDK contains drivers for the Z80 which control how the sounds are sent to the Yamaha chip. I don't know the specifics of all of these things. I'm purely a user in this. These functions here allow us to play an XGM file, and to play that, this is the references that we get. So to add more, you would literally just add another line here. Maybe it was MUS2, and then you would just change the name of this. We will add another WAV file in a moment, so I can give you a more detailed explanation of the parts that you need to do, because we need to, once we update our resource file and save that, we then have to delete this header file here. This is generated for us automatically, but we do also need to include this. So you kind of have to add stuff in. So you add in the files that you intend to include, like WAV or VGM. You then update the sound resource file, delete the sound.header file, recompile your project. The project will then generate the sound.h file for you. Then what you need to do is you need to include that header file so that you can access the array names. So these are obviously externally in databanks for us, already converted by SGDK. So as you could see from that, they are arrays. And then what you need to do is at the start of the program, or rather, sorry, at the start of your sound initialization, you see here I've got I access this function here, load samples. So all of the WAV files, you have to load them in here. So we use the XGM set PCM function here. So what this takes is an ID number, then the source array, and then the size of that array. So you'll see here that I'm using an enumeration here as an easy way to track the sound effects we add in. So sound effects IDs must start at 64 onwards. All of this can be found by digging into the various details in the SGDK headers here. There's various sort of header files, and there's also an online wiki with some more sort of details in these things. So your sound effect files can be between 1 and 63, and then your music tracks are between 1 and 63, and sound effects are between 64 and 255. So by using enumerations like this, it allows us to easily keep track of our assets. So if we added a new sound, we would also have to add it in here. And then at the start here, I set this to -1. So that it doesn't, if we open this up, so this will continuously play. In fact, no, this is, it will play once. And in fact, no, I think this is for the music, not the sound effects. So we want the music to loop. Obviously, the sound effects are one shot. So we only need to call this for the sound effects. And to use the sound effects, I have this function here. So to play a sound effect, you literally just call play sound effect, and then you pass in which ID you want using that enumeration. So here I'm using a random number between 0 and sound effects max, just for demonstration purposes. So to play a sound, you have to use XGM start play PCM. So there are various different ways you can play sounds using different sound drivers. I'm only showing you to do this one. You, by all means, use whatever kind of works for you. I'm just this is how I've found it to be simple to use. So to play a sound effect, you pass in the identification number, then a priority between 0 and 15. 15 is the highest priority and 0 is the lowest. And then you pass in which PCM sound channel to use. So according to the documentation in here, if you look through here, it says not to use channel 1, as that is mainly used for music. Here we go, that's used for music, so you can use channels 2, 3 or 4. And then by putting them on different channels, they'll obviously all be mixed together, so you'll hear the different sounds. So that's pretty much. I also put in a few other nice little things here, like pause the music. Wait there, that's not right. That's the one. There we go. And then there's also this here. So you can use this command here to check to see whether music's already playing. No, I've not done it in here, I don't think. No, but definitely check out some of these other XGM commands. So as this is at the moment, this is easily expandable and usable in your own sort of games here, but the next sort of thing that you need to know to or another program to use rather is a program called Audacity. So this program here allows you to load in different sounds, different sound files, and it will convert between them in various different formats. So what I'll do now is try and find where the yeah, here we go. So what we'll do is we'll load up one of these sound effects here, open it in Audacity, and we can see here that it's at 44 kilohertz here. So to use this, we will need to convert it into a different format. So one of the things I will do now is to change the frequency to a lower frequency. So to resample this down to 22 kilohertz, which is what I'm doing here, change the project rate first and then sample rate. And you see it's gone down to 22 kilohertz and it sounds the same. If you changed the format directly here, then you mess everything up. So some of the things we also do with this is you can change the pitch. So select all of that and then you get the idea. So we'll export that as a WAV file and then make sure it's an unsigned 8-bit PCM file here. And then that will then create that for us. So I'll close that now. Now if I go back to our resource folder here, you'll see it's there because that's where I saved it. And then we'll leave that all lowercase there. Now what we have to do is we need to add this to our resource list here. So start off with WAV for wave, and then we'll call it just my man, and it's in the SFX folder. And then this says at the end of it that it will use the XGM file player. And then we'll save that. Now what we need to do is we delete that header file there and we rebuild our project. So rebuild that. And then I'll bring this back across and I'll open this in text editor. There we go. It's created an array of bytes. So now that means we will be able to see it now. So if we go to SoundManager and then we add that into our enumeration there. Now if we come back into the SoundManager here, now we need to add that in to be able to play it. So add that in as part of our enumeration there, and then we have that there. Add that in, give it a priority of 15, and then we'll put that on Sound Channel 3. So now what we need to do is we need to make sure that we load that in at the start there. So we need this to play our new sound effect. And now we need to load it in at the start here. So we save that, and then if we repass the project there, it should be picked up now. There we go, it's found it. So that's all saved. If I rebuild this now, and then just navigate to back where that is built. Come on. There we go. So that's it for this video. I will upload the source code to this so you can have a play around and acquaint yourself with the SoundManager that I include here. Let me know if you've found this useful. And yeah, that's it for this video.